Okay, let's take a look at this. This is corner reinforcement. So corner reinforcement for beam supported two-way slabs. So if there are beam supported two-way slabs, then this is the corner reinforcement of those kind of slabs. So right over here, this is actually a column. So you can ignore that. This is just meaning the corner of it. Okay, so here L, longer clear span. So a slab, two-way slab may have a longer clear span and the shorter span. So if we take paint, I can show you there. For example, let's say right over here, let's say this is our slab. So this is the longer span and this is, let's say, the shorter span. So this is the longer span which they are talking about. Okay, so longer clear span. So here we go, L by 5, L by 5. So if the clear span is L, then the location for this corner reinforcement is going to be L by 5 in both directions. So A here, these A bars are top bars, and the B are bottom bars. So these are bottom bars. Okay, and C are equal to A, meaning C are also top bars. So 2 layers of top bars and 1 layer of bottom bar. Okay, so spacing of corner bars equal to spacing of maximum positive bars. Okay, so the maximum positive bar spacing is going to be equal to spacing of the corner bars. By maximum spacing of maximum positive bars, meaning that when structural designer is designing a slab, there are some bars that are required to prevent the positive moment, and those bars are given a certain spacing. So that particular spacing is also applied to the spacing of the corner bars. Alright, positive bars. So if we go to our bar detailing, there you go, we can see that the spacing is 10 millimeter, diameter 6 inches. 6 inches, the spacing is 6 inches, alternately timed. So here, the bottom plate, this is bottom location. This is actually for the positive moment, so 6 inches. So we're going to place 6 inches here as well. So this is going to be, the spacing of corner bars is going to be 6 inches as well. Okay, alright, so that's it for this video. I'll be seeing you in the next one.